Okay, this is Michael Pass with Team Admin at the University of Iowa. This is our Senior Design Lab 1. This is our minimum viable product. So what we have here is a digital thermometer, or a thermostat actually. And if I hold a temperature probe in my hand, we see that this one is sensor 1, and the graph starts to rise, and there we go. And then it's reflected there. We can also turn the graph off. So for sensor 1, it would be this. Oh, I got the colors right. That was a coincidence. So there we go. The button didn't register the first time, but that's just a mechanical issue. Probably not an electrical one. And then it stops graphing while the other one graphs, and we can turn it off as well, and they stop growing. If I turn it back on, it could be that it is a timing issue. If the loop is a little busy, we can fix that by creating some tasks. So this is a dual core ESP32, and there's also a little bit of flicker on the LCD, which probably is due to power consumption. I'm hoping the battery will help that, but then again, the power should be pretty good off of the laptop. So we can also turn the buttons on and off remotely, and this is all over the network. So even though it's connected to the computer, it's over the wireless network, and so we do this at the College of Engineering. So and that says turn on sensor, and then red is sensor 1, and it's kind of confusing because it's higher. I think of this as sensor 0, but no. So we can turn it back on, and we see the data. That's my cat who wants to get in. The other cool feature is we can, it enables you to, if the temperature goes above a certain threshold, and the current behavior is once it crosses the threshold, it won't alert you again, but it can alert. We also have up to 300 seconds worth, which is 5 minutes worth of data that it'll cache, and we've got this cool slider. We added this slider. It's not in the lab requirements, but it just wasn't nice to have the graph like be all the way for 300 seconds worth of data starting left and going up to the right, because it would take, starting with the program, 5 minutes for it to get there. So for debugging, that wasn't practical. So likely before it's due at 1:30, we're just going to add a little button here that says show full graph, and just it toggles the full graph on or off. It's just a little bit of code that modifies this slider, disables it, and sets the X-min and max value to 300 seconds from this point. And there actually is some logic, because if there's not 300 seconds worth of data, you start at the earliest point that you have and then extrapolate out 300 seconds worth. But anyway, we can these are the settings for notifications. So maybe this could be alert settings would be a better term, and because it's not very, if you're just new to this is the email address it goes out to. But this is a max, so if you erase it, it says max temp, so it shows the current value that's loaded. So this is the temperature threshold, so it's at 25 right now. So if I can make it hotter, which I'm hoping that my hand can get it hot enough, so let's try and set it below the threshold of -4, and then if we update the settings, it won't close, and it says maximum temperature must be greater than minimum temperature. So that's a requirement. So let's set it to a value that's reasonable. Let's set it to 27, I hope would be a reasonable value. Update settings. So that took, and then I can see if settings, so every time you click the settings button, it pulls it from the server. Also, you can we actually need to look at this. There's one feature, there's one last bug, one edge case we forgot. This temperature enter only works for Celsius, so we need to know, we need to look at the current temperature mode and interpret what the user is trying to say. Everything on the back end is in Celsius because the temperature sensors are in Celsius and the data is stored in Celsius. For the display, it should work on the display, and so it converts the values there appropriately. It's actually, whenever a data point comes in, it just adds its Celsius version in parallel. So we're actually keeping track of 4 data sets because we've got 2 sensors and then 2 degrees for each of them. So the performance wasn't always the best with this Fahrenheit, but everything seems to be working out really well, more so than it was at one point. But we'll go back to native Celsius. We ran into an issue initially keeping track of multiple points. Whenever you add one data point, even if, like, say a new data point from this sensor comes in, you have to add a data point for the other sensor, and that it's null. So yeah, just something to keep in mind. And the arrays that get sorted all have to be of the same size. So that's something you have to manage as well. There's another feature. Oh, I set it to 27, but let's see what happens if I actually set it to 27 and I'm making sure, okay, my emails are fine. There's nothing, I don't get weird things in my email as it is. So let's try with temperature 1 because it's the highest. So once it hits over 7, we should see something happen up here. So once it goes over 7, so that's 27. So it's currently so it's over now. So it should cross a threshold. Boom. Sensor alert, temperature is too high. So there you go. This has a really cool feature called hysteresis. So what would happen if I just set at that value, if there's a steady state value and I set the maximum temperature to that value, there's a little bit of noise on the sensor, because if it doesn't resolve to an even value, it'll kind of be up sometimes and low. So sometimes if you're right at that value, you don't want there to be constant messages that you're sending. So we have two kind of factors of hysteresis. One hysteresis in time and one hysteresis in value. Hysteresis just means memory, more or less. And so yeah, the hysteresis for value is exactly like a Schmidt trigger. You can look up Schmidt trigger. It's a very useful component. Anyway, basically if the temperature line is here, if it goes up and then crosses the line, nothing will happen when it's within that. But if it dips down far enough, then it'll reset this flag and it can be triggered again when it crosses the line again. So that's classical hysteresis, and I'm calling it value hysteresis. Also, the time lapse just shows how long ago it was. So that was a cool little function that we added into the chart. Matt was the one that put all this together from Node. He did a really good job with it. Again, the only thing that we need to fix is we need to have it so that this value, if the mode is in Fahrenheit, if the user enters it in here, it will convert it to Celsius on the fly. So that's something that'll take like 10 minutes at the most, if even that. Yeah, this video is getting a little long, but I'm almost through. Oh, the last thing is it has to detect when the sensor is disconnected. So if I kill the power, the values go to nothing. The NaN just means there's no value. We could have that show as something else, but that's just what it is right now. And then it takes 10 seconds to time out. So that's how our protocol works. And so but it's a lot quicker to reconnect. And we can get the timing if that's unacceptable. It's just changing one variable for the timeout. But that's for WebSocket data reliability. And then there should be a new data point and when it starts off, by default, the sensors are off, so I have to turn them on. So there's one. And then let's turn the other one remotely. Sensor 1, the red one, let's turn it on remotely. And then it's on there. So the cool thing is you can toggle it remotely and it shows up there. So, oh, and I think that's about it, but I've got to show you the absolute icing on the cake. The absolute coup de grace of functionality. So if I go to teamadmin.freedns, that's a DNS server, look what I got there. I think it takes a little while to pull all the data. There you go. Yeah, it had to pull the ring buffer, and now it's up to date. And now, check it out. Check it out. So if I click on the sensor, turn on, turn off, turn on. It's kind of weird to think because turn on is the opposite behavior. So we could maybe improve it by having these colors change if the sensor is on or off or something like that, because this logic is opposite to what you think in your head. And then if I pull the settings, if I change them over here, if I say 27, change the threshold to 1000 or something like that. Hold on, I'm having a hard time. There you go. 1000. And then the cool thing is if I click the update settings button, if it accepts, it'll go away, which I thought was a cool feature. And then if it doesn't show up here right away, it's because I'm editing it, but I haven't committed it. But then when I pull the settings, it's the most recent settings, so that's up to date. But yeah, this is a web app, so and it's written in JavaScript in a way in Node. Not really, well, using Node Package Manager for the chart.js library. This all is written so portable that it works pretty much on any device, and the slide works just as well on here. The initial delay, and this is probably going to be an issue, we probably won't pass specification. It has to display all the data within 200 or 20 milliseconds, or no, I think this is 20 milliseconds. This, I'm not sure what the time is as far as it has to display, but just given the sheer amount of data, it's not possible within 20 milliseconds to well, at least, so we could improve it by resampling less, but the chart's going to look way worse and much spottier if we don't sample as often. And so when the client first connects, all of the historic data is saved in what's called a ring buffer, which just means it's as soon as it hits a certain size, when new data comes in, it pushes out the old data. So you get like a rotating or a window of data that you can save. But anyway, we send the entire buffer when they first connect, and that's roughly I think 120 or 100 kilobytes or something like that. So a tenth of a megabyte, and that should be relatively quick, but it took longer than expected. And at that point, I'm just gonna throw my hands up and say we've done a good enough job for now. But that's what we've been working on for so long. As far as the Chat GPT, that's for documentation. Like I looked up how this slider works and like what these values correspond with and how to get it to work. I've kind of introduced it into my workflow for explaining documentation. It used to be when I was learning a new library, I would have to pore over like Java Docs APIs for hours and hours and still not really fully get it. And this kind of just gives examples when you do it. But yeah, that's how it is. Oh, and I can change the message. We could have custom messages. I just forgot to do it there. It would have been nice to show it off, but that's what we've got.